So the next question is, a sample of domestic sewage is digested with silver sulfate, sulfuric acid, potassium dichromate and mercuric sulfate in chemical oxygen demand test. The digested sample is then titrated with standard ferrous ammonium sulfate to determine the unreacted amount of C. COD test is used to calculate the organic as well as inorganic oxygen demand, right? And COD test, for this test we use silver sulfate, sulfuric acid, potassium dichromate and mercuric sulfate in chemical oxygen demand. In this test your dichromate ion converts it to trivalent chromium, Cr2O4 2 minus ion converts itself to, with in the presence of heat and silver sulfate, it changes itself to dichromate. It changes itself to chromium ion, trivalent chromium ion, right? And after cooling and diluting the mixture with distilled water, we can measure the excess dichromate remaining in the mixture by titration with ferrous ammonium sulfate. So this extra trivalent ion, by mixing distilled water and making it dilute, and by titrating it with standardized ferrous ammonium sulfate ion, we can find out the value of unreacted dichromate ion. So the option will be potassium dichromate, option B. Next question, a synthetic sample of water is prepared by adding 100 mg kaolinite, a clay mineral, 200 mg glucose, 186 mg NaCl, 120 mg MgSO4, 111 mg CaCl2 to 1 liter of pure water. The concentration of total solids and fixed dissolved solids respectively in the solution. So the total solids are nothing but the amount of everything. We can add 100 plus 200 plus 168 plus 120 plus 111. So it comes out to be 100 plus 200 plus 168 plus 120 plus 111 comes out to be 699 milligram per liter. And we know that clay is not dissolvable in water, right? So dissolved solids will be, other than this, everything is dissolvable. Glucose dissolvable, NaCl dissolvable, MgSO4 dissolvable, CaCl2 dissolvable. Only this clay mineral kaolinite is not dissolvable. So your dissolved solids will be total solids minus clay. So total solids are 699 and clay is 100. So the answer comes out to be 599 milligram per liter. So the correct option is option A. Now next question, to determine BOD of wastewater sample, 5, 10 and 50 ml of liquids of wastewater were diluted to 300 ml and incubated at 120 degrees Celsius in BOD bottles for 5 days. Results were as follows. Volume 5 initial DO 9.2, after 5 days DO 6.9, volume 10 9.1, 4.4, 50 8.40. Based on the data, the average BOD of the wastewater is equal to, we need to calculate the average BOD. There are 3 samples. This is the sample number 1, 2 and 3. So for sample 1, we can say that BOD, 5 days BOD will nothing be but initial DO. Initial DO is 9.2 minus final DO 6.9, and into dilution factor. Dilution factor will be the total diluted volume upon the volume of the this water, that is dilute. So it is 5, right? So after calculating, it comes to be 138 milligram per liter. Now for sample 2, the BOD 5 we can calculate. After 5 days, the BOD is 9.1 minus 4.4 into dilution factor 300 upon 10. It comes out to be 141 milligram per liter. And for sample 3, as we can see that this final DO is 0.0. That means the oxygen demand is fully done, right? We don't need any further oxygen. That means all organic compounds are decomposed in this. But we don't know exactly at what day, at which day it got decomposed fully, right? So if we don't know the exact data here, we can't calculate for third sample. So the average BOD will be for these two only. Average BOD will be 138 plus 141 divided by 2. It comes out to be 139.5 milligram per liter. So the correct option is option A.